Hello, my name is Kapil Kumawat and I am going to teach number system. In this topic number system, we are going to study about types of numbers. So, numbers can be broadly classified as real numbers or imaginary numbers. So, we'll study actually this imaginary number in 11th class. So for now I am just going to introduce you about it, that square root of negative numbers are imaginary numbers. For example, square root of -2 is an imaginary number. Why they are called imaginary? Because they cannot be represented on the number line. Okay? Now we are going to study about this real numbers. Real numbers can be classified as rational numbers and irrational numbers. Now, as the name suggests, rational is made of the word ratio, R-A-T-I-O, ratio. Ratio, which we have studied, the numbers which can be represented in the form of P upon Q are the ratios. So, similarly here also, the numbers which can be represented in the form of P upon Q, where P and Q are integers and where denominator Q is not equal to 0, are called rational numbers. For example, if we write 7, now 7 can be represented as 7 upon 1. Here the both numerator and denominator are integers and the denominator is not equal to 0, so we can say that 7 is a rational number. Similarly, if we write 2.5, or we can say here also this is a representation in the decimal form. We'll study further after this. So let's do the classification. So the rational numbers can be classified as natural numbers. As we have studied, natural numbers are the counting numbers. The symbol for this is capital N. Counting numbers are 1, 2, 3, 4. So these are the counting numbers. Can be classified as whole numbers. The symbol for this is capital W. Now along with the natural numbers, if we add a 0 also, then this collection of or set of numbers is called the whole numbers. Okay. Now another is, just a minute, integers. Integers are those numbers, or we can say the symbol for this is capital Z. So integers are a collection of or set of numbers having natural numbers, that is 1, 2, 3, 4 along with the 0, and negatives of the natural numbers, that is -1, -2, -3. So these numbers are called, set of numbers are called integers, and integers, as we can see, can be further classified as positive integers, that is Z plus, which are these actually positive integers, and also as negative integers, which can be represented as Z minus, which are actually these numbers, and as 0, as we can see it is a 0. Easy. Now if we write about the decimal expansion form, then rational numbers, if we write decimal expansion form, can be classified as, they can be classified as terminating decimal expansion and non-terminating repeating decimal expansion. Now the first one is terminating decimal expansion. If we write 5, what is 5? 5 is actually 5 upon 1. So if we write in the form of P upon Q, we can see that it is a rational number. And if we write In the decimal form it becomes 5.0, or we can say just 5. So after decimal point there is no numbers, so it terminates. Similarly, if we write 5 by 2, it is again in the form of p upon q, where p and q are integers and denominator is not equal to 0, so it is a rational number. And if we write in the form of decimal form, it becomes 2.5. so here we can see that after decimal there is only one digit, it is not repeating, and there is no digits further also, it stops here. So it is made of the word terminate. Terminate means stop, so it stops after 5, after the decimal point. So this type of number is called the terminating decimal expansion. So example, I am writing 2.5. okay. Now what about this non-terminating repeating? So if we write, let's say 1 by 3, so here again p and q are both integers and q is not equal to 0, so it is a rational number. And if we write the decimal expansion form, it becomes 0.33333 dot dot dot. So we can see that the digit 3 is repeating again and again, and it is not stopping. So since it is not stopping, it is of the type non-terminating, and since repeating, the digit 3 is repeating, that's why it is of the type a repeating decimal expansion. Okay, so the rational numbers can be written in the decimal expansion form in only two types. The first is this terminating decimal expansion, or in the non-terminating repeating decimal expansion, as we can see here. So its example is 0.333 dot dot dot, or we can say 0.3 bar. So this bar over this digit 3 shows that the digit 3 is repeating again and again. Okay, now what about this irrational numbers? So as the name suggests, the irrational numbers are those numbers which are not of the form rational. Irrational, the numbers which are not of the rational number, of the p upon q form. So the definition is the numbers which cannot be written in the form of p upon q, where p and q are integers and denominator, that is q, is not equal to 0. For example, if we write 5.125731023 dot dot dot. So if we see that, or we can say if we observe this number, the the number here is not terminating. The decimal expansion is of the form non-terminating, non-repeating. So the decimal expansion is always of the form non-terminating, non-repeating. So if we see that after decimal point, it is not stopping, it is not terminating. Dot 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 shows that it is, the numbers are there, so many numbers are there which is not written here, so we write 3 dots are there. So non-repeating, there is no single digit which is repeating, or there is no single or there is no set of digits which are repeating here, so it is of the type of non-repeating. So always irrational numbers are, if they are written in the decimal expansion form, they are always of the type non-terminating, non-repeating. Okay, now there are few numbers which are can also be written in the without in decimal expansion form, such as surds. So these are the number which are not of the type this decimal expansion form, but they are irrational. If we write these numbers in the decimal expansion form, they are always of this type, that's why it is irrational numbers. So examples are, if you write root 2 or root 3, so if we write the decimal expansion form of root 2, what are these? 1.414 dot dot dot. So if we see this, the number not stops, not terminate, and not repeating. There is no set of digits which are repeating. Similarly, if we write root 3 in the decimal form, it becomes 1.732 dot dot dot. So again here also the number is not repeating and it is not terminating also, so it is of the form of irrational. So how can we identify square root of what numbers are actually irrational numbers? So actually square root of non-perfect square numbers are irrational numbers.